everyone, I'm Duygu Gunay from HP 3D Printing, and today I will be covering some of the gaps in the current manufacturing processes that we use today and how 3D printing can enable you to have more production flexibility to reduce lead times as well as reducing costs. Today my aim is to introduce you to additive manufacturing, essentially what it is, how it can actually be applied to smart manufacturing, and what are some of the design considerations to keep in mind when you're first getting started with additive manufacturing. As you all might know, 3D printing falls under the general umbrella of Industry 4.0. This obviously includes IoT, big data, AI, and especially robotics. We've seen a lot of development over the past decade in robotics as more companies look to automate processes to reduce costs as well as improve processes in general. Over that same time frame, we've also seen a lot of development in additive manufacturing, where it's not just a novel technology, but a consistent manufacturing method that can be used, especially when properly used, to reduce costs and increase production flexibility for a lot of the manufacturers. When we talk about manufacturing today, we can essentially divide these into three different groups that you see here. Subtractive manufacturing, which is focused on removal of material, like CNC machining. Formative manufacturing, focused on injection molding or extrusion, or additive manufacturing, which is what we will be focusing on today. I think it's right to say from the beginning that additive manufacturing is not necessarily here to replace all the components that are being manufactured with CNC machining or injection molding today, but we choose to look at it as an additional tool in your manufacturing toolbox to complement these technologies to enable more agile production for a majority of our customers. And of course, when we talk about additive manufacturing, having been around for 30, 40, 50 years for some of the companies, there's a myriad of options when it comes to different OEMs that are providing 3D printing solutions, different material providers, and of course, different parts providers. When you look at the full list, even though you might be more familiar with some of the other technologies like FDM, fused deposition modeling, or SLS, selective laser sintering, when you first look at it, obviously this choice can be quite overwhelming when it comes to knowing which technology might be the one that is suited for your company in terms of technology as well as the business case. For today's presentation, of course, I will be focusing on examples from HP's 3D printing technology, multi-jet fusion, and the benefits of using this technology compared to traditional manufacturing methods as well as other 3D printing technologies. So we've looked at the long list of different technologies that you might be able to use. How do you essentially get to know which technology might be the right one for your company's needs? The essential choice comes down to two things, the process and the material. While these two things are not essentially separable from each other, as they do influence each other on different fronts, we can try to look at the different components under each of these to decide which technology might be the most sensible to use. So let's say that you have a very large part that you're looking to 3D print. That might narrow down the options of 3D printing solutions that you are able to use. If you have a component that requires high dimensional accuracy, that might also narrow down the options for you. If let's say that you have a component, end of arm tooling, or pumps, valves, other components that depend on fluid tightness, that might also narrow down the list of technologies that you are able to use. And of course, when we look at the material side, it's going to depend which kind of function that you are requiring from the components that you are using. Let's say that you need a flexible component, which means you would need to use elastomers. That also narrows down the list of providers or technologies or materials that you are able to use. Or let's say that you have a component that needs to be ready for a high temperature environment. That also means that your options are going to reduce quite significantly. When we look at all of these things, essentially the choice point comes down to these technical requirements, as we've covered here, as well as the business requirements that you are looking to achieve within your company. Of course, we've talked about all the different components that you might look at, but let's see how HP's 3D printing technology, multi-jet fusion, compares to these traditional manufacturing technologies, as well as other 3D printing technologies available today. So compared to injection molding or CNC machining, one of the biggest benefits of 3D printing is on cost and lead time savings, especially for short runs of final series production, so production in the hundreds, thousands or 10,000s. This is essentially where we see the benefit of 3D printing shine. As you're seeing with costs, as you're manufacturing with injection molding and CNC machining, 3D printing enables you to have the flexibility to get rid of minimum order quantity or making molds or remolding some of these molds that you're doing as you're integrating changes to your product. So that gets rid of a lot of the cost and lead time associated with manufacturing that we are restricted by today. One of the more exciting components is, of course, the new and complex designs. With 3D printing, with topology optimization or generative design, you are essentially able to create these organic designs that are specific to the task at hand that you're trying to perform. And essentially, by being able to leverage all these software developments, you are able to create customized components that optimize the performance of the part that you are using today, which touches quite significantly on the customization component as we talked about. With 3D printing, we see a lot of our customers doing things that they weren't able to do with injection molding or CNC machining, creating parts that have much less components compared to what they would do with CNC machining or injection molding, or creating parts that have multitask performances. So combining these designs together to save time on the production, on the assembly, or even save operational space, or reduce the size of the components to make up space within a machine or on the operation line itself. And of course, one of the biggest components is production flexibility. When it comes to getting components from the different suppliers that you might have distributed worldwide, it might be quite significant. It might have a quite significant impact on your project development. So if there's a delay in one of the suppliers that you have in one of the countries that you're working with quite often, that might affect your product development process or your production process quite significantly. With 3D printing, having an in-house 3D printer that is able to print in hours or days and fulfill these requirements, may it be a customer request for a spare part or a jig or a fixture on the production line due to a change in the production line or change in the product that was being processed, 3D printing essentially enables you to have that flexibility and agility to meet these problems that come up unexpectedly head on. How does HP's 3D printing technology compare to other 3D printing technologies? One of the biggest components of HP's technology is obviously it's a powder bed technology where the powder is distributed along the print bed layer by layer and then fused with different agents. The durability component becomes a huge benefit of using HP's 3D printing multi-jet fusion technology. You may have experimented with FDM printers, desktop FDM printers that create some of the prototyping parts in general, but what we see with a lot of the layer-by-layer technologies that don't necessarily focus on powder bed is that the strength that you have for the part on the X and Y direction might not essentially be the same on the Z direction. With powder technologies within 3D printing, you essentially are able to kind of keep that same level of strength for X, Y, and Z direction, which increases the durability of the component and enables it to be incorporated into production-ready environments. Another big component is, of course, design freedom. As we've talked about it, the powder bed itself acts as a support structure for the final design to be created. With other technologies that focus on extrusion or other methods, you might need to use support structures to be able to create the final component that you desire, that your engineers have designed. With HP's technology, you don't necessarily have to do that, as the powder itself acts as a support structure, and you are able to create more organic designs without wasting more raw material. And that connects quite heavily with the sustainability aspect. While you're 3D printing, compared to any traditional manufacturing technology, you're using the material that you need. Especially in HP's case, where you're not wasting raw material with the support structures, you are able to save on cost as well as becoming more sustainable when you're 3D printing. Another component is, of course, material recyclability. HP's materials that are available in the market today have material recyclability of 70 to 90%, which is quite high compared to the rest of the 3D printing technologies that are available in the market today. And of course, depending on how you choose to use the technology, we see two different approaches. Some of our customers are using 3D printing and installing 3D printers in regional hubs and treating those regional hubs as fulfillment centers for the countries or their other offices that are in that area for the 3D printed components, which reduces the carbon footprint of enabling that from a certain location to worldwide. So these are all the different areas that we've seen the benefits of 3D printing compared to traditional manufacturing, or HP's 3D printing technology compared to other technologies. How does the technology actually work? HP's jet fusion printing process essentially focuses on this powder bed technology that uses two detailing agents. The two agents that are used here are the fusing agent, which helps fuse the powder that is going to become the final part itself, and the detailing agent that is deposited on the cross-section boundaries to make sure that you have crisp details that you need, that you would be able to achieve with injection molding or CNC machining. After that process is fused with heating lamps that are distributed around the print bed equally, then you would essentially move on to the next layer for the process to repeat again until the entire powder bed is filled with the components that you are able to print. We've talked about the technology, so what kind of printers does this technology work on today? HP has two different production available solutions today, the 4200 series and the 5200 series. And you can see the different rigid and elastomer materials that are available for both of those. On the 4200 series, the PA11, PA12 glass beads, as well as the TPU material is available. And on the 5200, the PA12 glass beads, PA11, PP, and TPU materials are available. What are the differences between these two solutions? One of the biggest difference is the automatic unpacking station that is available for the 5200 solution. As you can see here, we talk about the 3D printing solutions in general, but you see two different machines here. Next to the 3D printer, you're seeing the post-processing station, which is essentially used for the material loading, pre-printing, which we also already talked about the material recyclability, where you're having the used material as well as the new material being mixed before the printing process. And after the printing process, that same printing bed, the build unit, is processed back on the post-processing unit for the unpacking, which is getting rid of all the powder that hasn't been used to become the component that you 3D printed itself. The automatic unpacking station for the 5200 series essentially enables unattended and rapid unpacking of that print bed. It reduces the manual handling of the material powder during the unpacking process and makes the process quite easy end-to-end in terms of the workflow. It also increases the build-to-build unpacking consistency, where you're not dealing with manual labor along the process of unpacking and cleaning your parts. And on these printers, there's of course a myriad of different options for applications that you could 3D print. Majority of our customers, as you can see here, are in this four different industries. On healthcare, we see a lot of our customers 3D printing medical equipment components, dental applications, orthotics, prosthetics, and surgical guys. For industrial, which I will deep dive a little bit further on, in the upcoming slides, we see a lot of our customers 3D printing machinery components, a lot of components for automation, and of course for mobility and transportation, you will see a lot of automobile components, maybe within the automobile itself, or buses, trucks, tractors, or boats or yachts. Also some jigs and fixtures that are quite necessary that they are using on the production lines themselves. And for consumer goods, we do have a lot of applications, from lighting to sports equipment with helmets to eyewear and so on. But for the purpose of this presentation, I will focus a little bit more on the applications we see in the industrial space. A lot of our customers, we see them 3D printing end-of-arm tooling. They're leveraging the benefits, the design benefits of 3D printing as well as multi-jet fusion to create lightweight, customized end-of-arm tooling that enables smaller robots that create a lot more operational space, that reduce the energy consumption of the robot as well as the entire robotic system. So this is one of the ways that within the industrial space, we see 3D printing kind of shine as a hero application. We also see a lot of components when it comes to mechanical. So any kind of mechanical housings, electrical components housings, bearing cages housings, or drives, pulleys, or gears. Another big benefit of 3D printing within the industrial space is, of course, on jigs and fixtures. For those lines that you might need common changes, easy changes for the products that are passing through the production line, a lot of our customers are leveraging 3D printing for those go-no gauges, inserts, and other components that you might have on the production line. And of course, we've talked about fluid tightness or air tightness. For those applications, we see a lot of our customers printing heating, ventilation, air conditioning, any kind of fluid system from pumps, valves, to turbines, to irrigation systems. Another part that we see within the industrial ecosystem is, of course, for changeover and spare parts. A lot of our customers are leveraging 3D printing to be able to respond to requests of spare parts much faster compared to injection molding or CNC machining. This process, of course, one, increases customer satisfaction when you're able to deliver those parts in hours or days, depending on their location, compared to weeks or months, which is what we see a lot today in the manufacturing space. And it also enables a lot of our customers to reduce their inventory and warehousing costs. Being able to 3D print on demand when you need the part, wherever you need the part, enables a lot of our customers to cut down on all these additional costs that go along with the inventory or warehousings or logistics delivery of the components themselves. With that, I'll try to share a couple more examples in detail from our customers that are using HP 3D printing solutions. Of course, we've talked about the time and cost savings. This becomes a big component. As I mentioned, these three concepts here are not necessarily separable from each other. But one of our customers, HP APCC, this is a customer that has 19 packaging lines in their facility. And they're using the MJF technology for all kinds of end-of-arm toolings for the different cobots that they have in-house, a lot of jigs and fixtures, so sensor brackets, inserts on their production lines. And essentially, they've been able to reduce their costs 80% overall for the components that they need on their manufacturing lines. They have saved almost $500,000 on a little shorter than 3 years, which is quite a significant achievement when it comes to time to part and cost savings with 3D printing. Another example, once again, a little bit more on the exciting side, is the rethinking the way that we design. Baumann is one of our customers here from the UK. They're manufacturers of bearings, and they are producing the bearing cages or the seals with HP's multi-jet fusion technology. This product, by the way that they design it, not being limited by the constraints of injection molding or CNC machining today, they are able to improve the performance of the part itself. So they were able to increase the load capacity of the bearings up to 50%, which also increased the lifetime of the bearings between 3 to 5 times in general. So this is another way that we see the way that you design really can affect the performance of the component that you are producing today. Another big component is, of course, sustainability. We've talked about the material recyclability. We've talked about being able to reduce your carbon footprint by being able to produce the components that you need on demand. Havatech is also a good example for those of you that might think that all of that sounds great. It seems like there are a lot of opportunities here, but I may not need that. I may not have that many components to 3D print. How would I justify adopting a 3D printing solution for, let's say, 10 of the machines that I have? Havatech is a manufacturer from the Netherlands. They're producing flower bunching machines. And essentially, that machine, they're selling 15 units of that machine annually, which you would imagine initially that wouldn't necessarily be a good candidate for 3D printing. But their engineers have essentially been able to identify 200 different SKUs in that machine itself to be able to be redesigned with additive manufacturing and incorporate into the part itself. They're also using the HP's PA11 material, which is a plant-based material, which also helps reducing the carbon footprint of the products that you're manufacturing today. These are some of the examples from our customers, and although this story might sound good or bad to some of you, I wanted to take you through some of the processes that our customers go through when they're first getting accustomed to 3D printing. We see a lot of different approaches from our customers when they first get into additive manufacturing. The process can be, of course, very different. When you're first getting into additive manufacturing, essentially what you're getting rid of is that tooling cost, the tool wait time, minimum order quantity, with majority of the technologies that you use today. And with 3D printing, essentially you are able to cut that part out and design, print, and then post-process, and then test the parts. When you're going through the normal process of part design in new product development, if you have changes to the part, that essentially means new molds being made. That means new costs, new wait time, which will add on to the product development process. With 3D printing, you are able to get rid of those components to be able to, let's say, design different prototypes, different stages of a prototype, print them at the same time in hours, test all of them at the same time, and then integrate any design changes that you might need into the part, and go ahead with printing again for the final testing in general. So as engineers, this process is of course super, super painful for a lot of the different companies, a lot of design teams, a lot of engineering teams. And what we see with additive manufacturing, of course the story makes sense when you're talking about the design for additive manufacturing, but where do you essentially start? It all sounds good that you have to get a part, you have to design it, you have to print it, but where do you start? Well, how do you look at your own parts portfolio to identify what parts would technically and financially make sense to 3D print? Once you've identified those parts, how do you design for additive manufacturing? That knowledge might not necessarily exist within your organization at the time where you're adopting a technology. So I'll try to give it three different scenarios of our customers' behavior on how they adopt the technology. It really depends where you are in the product development process. We see a lot of our customers, when they first get the solution, take a look at their parts portfolio and look at the designs and then try to transition them into additive manufacturing. This is essentially the first case that we have today, and we talk about it as when you've designed yourself into a corner. Let's say that you have a part that you have been manufacturing in the same way, in the same method, with the same design for the past 10, 20 years, and no changes have been integrated into part because it hasn't been necessary. For those components, in cases where, let's say, lightweighting or material cost, reduction of material cost might be beneficial, 3D printing allows you some tools to play around with the design of that part, like hollowing certain structures to reduce the material, or using lattice structures to keep the same performance, durability of the component while using less material and having more organic designs. Another part, of course, as we go along, so that's of course when you're dealing with a component that has been designed the same way and has been used the same way for a very long time. As our customers adopt the technology and their engineering teams, their design teams get more comfortable, essentially their eyes kind of open to new possibilities within their organization. They kind of start looking at different components within their organization with a 3D printing eye to see what could be 3D printed. So a good example of this is the component that you see here. This component was CNC machined previously. It consisted of 8 different parts, and it's quite heavy. I don't really have it here with me, but it's quite a heavy component. And this part was redesigned for HP Multijet Fusion to be 3D printed all at once. And they were essentially able to optimize the flow for the tubes that you see here, which improved the performance of the component itself. And with any fluid tightness or air tightness application, as you can see, this being able to 3D print this in one component enabled getting rid of all of these joints and junctures that you have in the CNC machine component, which would result in, air leakage potentially. So these are all the different components that you can see that have been consolidated. And in addition to all of the performance benefits, you can see that the cost reduction was up to 95%, as well as the weight reduction of 93% for this component specifically. And of course, as we talked about it, as our customers get more and more comfortable, then they will start looking at the new designs that they need to come up with the 3D eye from scratch. So how would a part look like if you're designing it for 3D printing, for additive manufacturing from scratch? This pneumatic grip is a good example of that, and you see 4 different iterations of the design. The first 2 designs are essentially the testing designs for the performance of the part, for the validation, for air tightness, as well as the task at hand. And for the 3rd iteration, they essentially came up with the pneumatic grip design. A problem that they saw with this iteration was the gripper fingers were not aligning up perfectly. There were a lot of non-linear motion when it came to the motion of the gripper itself. And they created this quite complex structure that you see on the 4th iteration that one, help the movement to be quite linear, as well as creating a stop for the back end of the grippers themselves. This part also has been 3D printed all at once, and these are the things that you can see, you can leverage for these components. And this component itself has been manufactured by IM3D Hub. It's being used on Continental's lines in Spain, and it has been tested for a fatigue cycle of 1 million open and close. As we've talked about all of this, of course, you might be thinking, okay, what is a good method of getting started with 3D printing? One of the best processes would be speaking to providers, speaking to OEMs that provide 3D printing solutions, not necessarily just HP, but a lot of the other ones as well, to see exactly which material, which technology, which process, which provider is the one that fits to the company's needs, technical or financial. Another part is, of course, a lot of these 3D printing solutions come at a cost. 3D printing ecosystem doesn't necessarily just consist of the OEMs that provide these solutions. There are a lot of parts providers that actually house a lot of the different 3D printing technologies today, probably very close to wherever you may be, that might give you that expertise on, or those guidelines on, probably for what you need, let's try these two technologies. Let's test it on these two different technologies. Let's try these two different materials to see what fits your needs the best. And they also might be able to help you on the designing for additive manufacturing front. For something that you may not have expertise on today, they might be able to help you in designing the components or changing the design of the components to fit additive manufacturing without losing the performance or the durability of the component itself. And those people are kind of the people that can guide you throughout your adoption process in general, and that could actually be a more cost-effective way of getting started with additive manufacturing until you come up with a business case within your organization to justify an investment for a 3D printing solution. This concludes my presentation in general. So if you have any questions or if you have any concerns, feel free to connect with me after the speech, as well as feel free to connect with me on LinkedIn, and I'd be happy to answer any of the questions that you might have. Thank you.